Hello everyone, and welcome back to another GIS lecture video. And in this GIS lecture video, I want to continue our discussion on reviewing basic statistics by talking about the median. So in the previous video, we talked about mean and how it is the summation of all of the observations divided by the number of observations. And then it gives a really good sort of graphically, right, again along a number line, it's a really good estimate of where the center of that data set would likely be. Another way that we can estimate the center is through what's called the median. Through the median. Sometimes you'll see this called the 50th percentile, the middle number, the second quartile. Right, these are all different descriptions for what's called the median. Now, middle number is not really mathematical, but I think it's a good description because what we're doing when we're trying to find the median is we're actually trying to find the number in the middle of the data set. And in order to do that, we have to do two steps. Before we can find the median, we have to make sure that we have our data set ordered. So step one, right, is going to be to order the data set. Right, take this data set and order it. What I mean by that is not go online and send a request to get the data. No, what I mean when I say order is to set the data set up so that the observations are in numerical order, meaning that the first observation in the data set is the lowest value, increasing until the last observation has the highest value. Okay, so let's go ahead and order this sample data set here. Well, our lowest value is going to be 2, right? Because 2 is the lowest value. So it's going to be our first observation in our ordered data set. The next lowest is 3, followed by 5, followed by 6. And then finally, our highest sample is 10, right? So you can see I haven't changed any values. I haven't added any values. All I've done is reordered them so that 2 is the lowest and 10 is the highest. So once we're confident that we have an ordered data set, then we can move on to step 2, where we actually calculate the median. Right? And so in order to calculate the median, there actually is an equation. But that equation depends on whether or not n, right, the number of observations in the data set, is even or odd. Right? Because you can imagine if we're trying to find the middle number, right? In one scenario, the middle number is literally just the number that is in the middle, right? In another, right, there is no middle because you would end up having an even number and there's no integer division for the middle of an even set. So let's go ahead and start off by talking about what happens if n is odd. Right? What equation do we use if n is odd? Which in this case, n is odd, right, because we have 5 observations. Let's think for a second. What number are we looking for, right? If we ordered our data set, the middle number is going to be the one at observation 3, right? 1, 2, 3, 4, 5, right? This observation here cuts the data set in half, right? It's the middle number, and it's indexed at position 3, right? So we're looking for position 3. Well, how would we get position 3 out of this? There's a nice equation for that. If n is odd, right, we're going to index the data set. So in this case, x, this big X here, represents the data set. Right, we're going to index the data set at position, right, these brackets mean index position, n plus 1 over 2. Right, because n is odd and we want to go halfway, we add 1 to make it even so that we can divide by 2 to get an integer, and then we'll get the position that we want, right? Because in this case, right, again, think 1, 2, 3, 4, 5. The middle was position 3. In order to get that, we added 1 and then divided by 2. So when n is odd, our median is going to be the value at location n plus 1 over 2. So in this case, right, our n is 5. It's going to be 5 plus 1 equals 6 over 2 equals 3, right? And we would go to position 3, grab our 5. So in this case, our position was 3, our value is 5. So we'll add that here to this little diagram here. Okay. We'll come back to interpreting the median in a second. But what I want to do is I want to then talk about, well, what happens if n is even, right? And for the sake of argument, I'm going to make another value here for 11. So this is, I've added a sample, so we now have an n of 6. Well, what's the middle value? Well, there is no middle index because n is even, right? So what would happen is our median conceptually would be a number somewhere between 5 and 6, right? So it's going to be somewhere between position 3 and position 4. So how do we calculate that? Well, we calculate that by getting the value at position 3 plus the value at position 4 and then dividing by 2, so we get an average of these two numbers. Okay? So what does that look like in terms of our equation? Well, it's going to look something like this. It's going to look something like the value. So we're taking the data set and we're indexing it at n over 2, right? This is going to give us, because our n now is 6, right? So we have 6 observations, 1, 2, 3, 4, 5, 6. We have 6 observations. So if we divide that by 2, this is going to give us our position 3 that we needed, plus, let me slide over just a little bit so we have a little bit more room to work with here, plus, right, we now need that position 4. Well, that is going to be, in order to get a 4 out of here, we're going to want to do n plus 2 over 2, right? Because in order for this to give us an integer, this numerator has to stay even. So if it was even to begin with, in order for it to stay even, we have to add 2 to keep it even, divide by 2. So in this case, that'll give us position 4, right? So this is going to give us position 3, which is 5. This is going to give us position 4, which is 6. And then we're going to divide that by 2 to get our actual median, because it is going to be the number in between the value at position 3 and the value at position 4. So in this case, it would be 5. So in this example that we've extended here, right, if n was even, it would be 5 plus 6 over 2. It's going to be 5 plus 6 is 11 over 2, 5.5. So you can see here, by adding an 11 on the end, making our n even, we've increased the median from 5 to 5.5, which is the number that is in between 5 and 6, because there's no single value when n is even. You have to take the average of the numbers on either side. So let's talk about conceptually what this median does for us. So visually, right, what this median does is it's another way of estimating the center of the line, right, between 2 and 10, right? It's another way of estimating that central tendency. What the median also does is it also provides a number that is that has the minimal difference from every other number in the data set. And this will make a lot more sense when we talk about it in a geographic context. But if you were to take every number and subtract the median, right, this would be the number that is the least different from every other number in the data set. Okay? And like I said, if that doesn't make sense right now, that's okay. But just keep in mind that this median is the number that has the least difference from every other number in the data set. From every number in the data set. Okay? And we'll come back to this idea again in the geographic context. But for now, Just remember that median is another way to measure the central tendency of a data set, and that it is the number that has the least difference from every other number in the data set. And that is different from the mean because the mean, depending on outliers, may be farther away from some values than others. And this will make a lot more sense in future lectures. But anyway, as always, if you have any questions, please reach out. Thank you.